Okay, uh, so let's talk about the next chapter, that's electric field. So, an electric field is a region around a charged particle where other charged particles experience a force. So, the direction of the electric field is the direction of the force that a positive test charge would experience. So I think you all are kind of familiar that the strength of electric field is measured in volts per meter, B per M, like this, and some examples like the electric field around positively charged object points radially outward, like plus Q charge will the field generated by this charge would be like this radially outward, and in contrast to this positively charged particle, the negatively charged particle, the electric field around a negatively charged object or particle points radially inward, okay, like this. So this is how the fields are represented for positively charged particle and negatively charged particle. Also, the electric field between two charged objects is attractive if the charges have opposite sign, and repulsive if the charges have same sign. So it's kind of well, you know, a known fact. The electric field created by a moving charge is perpendicular to the direction of motion. So I think these all kind of ideas are uh, very known to you all. So I think let's try to solve this problem, and that will help you understand how this motion works. Okay, so the problem is from chapter 24, problem number 59. Two metallic spheres of same size with charges positive 9 microcoulomb and negative 4 microcoulomb are kept 0.20 meter apart. So we have to find the location where electric field is 0 if 9 coulomb charge is placed at origin. Okay, so we can consider that the point P somewhere here at this location where the electric field is 0. So that's it, and let's assume that the distance from this origin to that point P is x, so that the distance from this point P to the position or the location of the another charge Q2 minus 4 microcoulomb is 0.20 meter minus x. So the total distance from these two charges will be again 0.20 meter. So at point P, according to question, let's assume that the field is 0. The field produced by these two charges is 0. So that means sum of fields produced by these two charges is 0. So doing that, so let's try to express the field for the charge. The positive charge 9 microcoulomb, let's suppose that is Q1, and another charge as a Q2. So this is for the charge Q1, and this is the field for charge Q2. So the distance of that charge 9 microcoulomb from point P is x distance, which is clearly shown on figure, and the distance from distance from point P to the another charge Q2 is 0.20 minus x. Okay, further you can solve this quadratic equation of this form, which is like ax squared plus bx plus c equals to 0. And whenever solve this type of quadratic equation with formula x equals to minus b plus minus square root of square minus 4ac over twice a, that's here the b is minus 3.6, so the negative of the negative minus 3.6 would be this positive 3.6 plus minus, so the two roots will be the value of x, so that's why plus minus, and you solve that, you'll get this value, and we can have positive and negative roots, the values of x. So if we choose a positive value, you will get 0.6 meter, which is not possible, as this distance is more than the distance between two charged particles, so it's this value is discarded. So when you take negative value of this 2.4, so you will get this value 0.12 meter, so that's the point the point 0.12 meter from plus 9 microcoulomb is the location where the net field produced by two charges is 0. So this is how you can solve such type of problem.